And 4 we're going to use kind of as a warm-up is square roots. On the back of the sheet you picked up on the way in, I want you to list the first 12 perfect squares. Perfect squares like 1 times 1 is 1, 2 times 2 is 4, and so on. So the first 12. There you go. You got about 30 seconds. Okay, everyone, the next one. 9 and okay. Okay. All right, so we've got our first 12 up there. And it still won't focus, but that's okay. All right. How many of you know the next one? 13 squared? Yeah? Good. 13 squared is 169. 14 squared? Yeah? 196. Just flip the back 2 numbers. Okay. Next one? Yeah?
225.
225 is 15 squared. Okay. Next one? Mackenzie? 256 is 16. 17? Yeah? 289. 89. 18. 324. 19. Yeah? 361. 20. Yeah? Good. 20 is just 2 times 2 with 2 zeros. 400. Okay. Very good. So if I'm taking and I want to know, if I know that like 25 is 5 to the 2nd power, that means the square root of 25 undoes that power. It brings me back to 5. So square root undoes your exponent. Okay? So it's good to be able to recognize perfect squares, because if I take the square root of a perfect square, square root of 81, that brings me back to the number that I squared to get here, which is 9. Okay? These are called the principal square roots. Principal square root means when you take the square root of a number and you're taking the positive value of it, that's your principal square root. Now you could have a negative sign out here. If I said I wanted the negative root of 100, well, the root of 100 is 10, and then I just put the negative sign at the end. It's like having negative 1 times that. Okay, so you could have a negative. You can't have a negative inside and get a real answer. However, you can have a negative on the outside. Okay? Questions? Hopefully that was a review. I want you to take a look at the worksheet you picked up real quick. I want you to go through set 1 and set 2 without a calculator, please. Set 1 and set 2 without a calculator. You get the next 4 minutes. Go. All right, here we go. Number 1, Bobby.
5.
5. Number 2, Keegan.
-9.
-9. Number 3, Caden.
Is it positive or -12?
Plus minus 12. Good. Number 4, Mackenzie. 11. Number 5, Chelsea.
8.
Almost.
-8.
-8. Good. Number 6, Jennifer. 13. Number 7, Patrick. -15, yeah. Number 8, Cole. Number 9, Toki.
17.
Number 10, Jaden.
-4.
Number 11, Audrey. Good. So right here we have the root of 196 is 14. So the root of 1.96, just 1.4. Just put the dot and the decimal in between there. Nice job. Okay. Number 12, Ryan.
0.19. 0.1.
Almost.
Is it 1.9?
1.9 plus minus 1.9. Good. Number 13, Parker.
-0.9.
Nice job. Okay. Number 14, Lily.
1.2.
Good. Number 15, Marie. 0.8. with a negative, right? Okay. And Ayla, number 16? 1.5. Good. Number 17, TT?
Plus minus 1.3.
Good. Number 18, Brendan? Point zero. 02? Yeah? I think it's just going to be point 2. 0.02. Or negative 0.2. Yeah. Okay, remember when we multiply a decimal by itself, you're going to have two numbers behind the decimal. So if I did 0.2 times 0.2, and then I'd have our two numbers there. Okay, Jake, number 19. Okay, what's the root of 25? So it would be 5, right? And then with the decimal, you got the 0.5. Good. Okay, and Jaden, number 20. Okay, so what's the square root of 324? Back to your perfect square list. What we did at the very beginning of class. How many prior to 400 is it? So here's 20. That's 19. 18. So we got 1.8. Negative 1.8. Guys, the reason we did that square root list at the beginning was so you could have it out in front of you. So every time you're dealing with square roots, top of your page, write down the first 20. Okay? In fact, well, we could do it later, but you guys could quiz me. I could give you any I could square any number from 1 to 125. 126 in my head. Like, give me one. Go on. You can check. Go ahead. Yeah. 48. That is 2304. Check it out. Someone's got to check it. You can't just take my word for it. 48 squared, 2304. Yeah. All right, come on.
27.
Huh?
27.
27? Yeah, that one's going to be a little tougher. Hold on a second. 27 is 23, so 2, and then 5, 29, so 729, I think.
Yeah.
Okay.
43.
43, so that's 43, so that's 1849. 59? That's 3481. 69 is 44, and then 361, 4761.
Yes. 129.
Huh?
129.
I don't know anything above 126 because the only reason I can do them up to 126 is because I know all the perfect squares up through 26. 124 is 148 15376. 72. 72 is 22, so 47, and then 22 squared, 484, so 11084. Is that wrong? Ah, I got lost on that one. So let me show you how I'm doing them. So what is it? What did you just ask, Jake? 72. So 72 is 50. Now this is just, it's 50. I start at 50. That's 22 above 50. Right? So I drop down to 25 and I go 22 above 25, which is 47. And then I square 22, which is 4. That's where I made my mistake. 484. And then I add that, that's 5184. Okay. Pretty cool, huh? Yeah. I'm doing perfect squares between 1 and 126, Mr. Vogel, in my head.
That's your gimmick, man. I have no idea how it works.
Yeah. I love it. All right. Anyway, It's pretty cool. Just saying. Thank you. All right. So let's move on to number 21. Everyone taking 21. Anytime we see a fraction, we're going to break it into its different parts, the numerator and the denominator. So root 4/9 can be thought of as root 4 over root 9. Okay. What's the root of 4? The root of 9? There we go. That's our answer. That's simple. So break the numerator into a root, the denominator into a root. We call it good. So I want you to go through 30. You've got about 2 minutes to work on it. Okay, let's see how we did here. Toki, what did you get here?
Plus minus 5 over 6.
Plus minus 5 over 6. Very good. Audrey, right here?
I got -1/6.
Good. And Mackenzie?
7/9.
7/9. And Caden? Good job. And Parker?
3/7.
Good. Ryan?
Plus minus 2/9.
All right. Patrick? Cole? All right, good. And Jennifer? 12. Well done. Any questions on those? TT?
And number 29, would you reduce it down?
Ah, good question. Yeah. So could we reduce that? Yeah, we could. What goes out of both 6 and 15? 3. How many 3s go into 2 or 6?
2.
Unbelievable. And 3s into 15?
5.
5. Yes, you could reduce. Always reduce if you can. It's a good question. Yeah, Mackenzie.
If that was on the test or the quiz, would we get marked down points if we don't?
It depends what I'm checking out. Probably on this, I wouldn't have marked down on it, but it's a good idea. And when you do any kind of entrance exams or in-course exams, standardized tests, they're going to give you it in reduced form. So it's a good thing to practice. All right, let's move on to set 4. Set 4, you'll notice the difference between right here where you just have a square root symbol, and here you have a little 3. This thing is called an index. What do you guys think it means? I need to engage you two because right now you're both staring off into space. So what does the 3 mean? Nope, that's what this one means. We hide the 2, but it's there. That means square root.
Is it the opposite of cube?
Yeah, it's like the opposite of cubed. In other words, what does that mean?
B2.
Yeah.
Cube root.
Cubed root, what's that mean though?
What 3 numbers make it?
Yeah, what number times itself 3 times makes that. So what number times itself 3 times makes 8?
2.
2. And if you don't know, you start like 1 times 1 times 1, that's 1. 2 times 2 times 2 times 2 times 2 times 2 is 8. So you could list your perfect cubes right here. So 2 cubed is 8. 1 cubed is 1. What's 3 cubed? 3 times 3 is 9 times 3 is 27. So 3 cubed is 27. So it's good to recognize some of those. 4 cubed is? Yeah, it is 64. Okay. If I were you right now, I'd list at least the first probably 6 perfect cubes. So I'd get 5 cubed and 6 cubed up here. Okay. All right. Give them a go there. All right, let's get some of you up here. Number 32, who's got 32? Come on up, put the answers. Go ahead, TT. Number 33. Gonna put up 33. Mackenzie, thank you. Number 34.
I asked a question.
Number 30. Oh, okay, I'll come over. But you still get 33. Thank you. Hey, 34? Yes, Kate, thank you. 35? Got 35. Lily? 36? It's all from this side. Come on. Come on. Yeah, Chelsea. 37. Jaden, 37. Thank you. 38. 38's tougher. 39? Someone from these guys here? 39? 39, Ryan? Yes, thank you. And 40. Who's got 40? Someone in here? Yeah, one of you guys get 40. Thank you.
Wow, okay, I see how it is.
I think it was picking. These are all so big.
Because you're Ryan.
We got
What is it? 39.
Jeez, don't be rude, Bobby. Why are you booing him? That's rude and unkind. That's rude and unkind, Bobby. You shouldn't be booing. You shouldn't be booing kids.
I'm off the stage.
That's rude.
Ooh, look at that perfect handwriting.
Good handwriting, I'll agree. Holy cow.
That's
Well done.
It's the little next stuff.
Who did 38?
Yeah, no one had 38. You guys, this is read as, anyone know how we read that? Rather than 0.008?
8 to the power of negative
Yeah.
3.
Good. 8 1,000ths. There are three numbers behind the decimal. If you think of the number 10 or 100 or 1,000, well, which one of those has three zeros? 1,000. So we call that a 8 1,000ths. Okay? Which is good when we think of it like this. We are saying, what's the cubed root of 8 1,000ths? The negative cubed root. Okay, that makes it a little easier when you see it like that, right? Because the cubed root of 8 is 2. And the cubed root of 1,000 is 10. And so that's negative 2/10. Okay? Any questions? All right. My goal was to be done at 45 after. We're 1 minute past due. But that's okay. Between what two consecutive integers is each square root? So think of the perfect squares. What number, which two perfect squares does 19.4 fall between? Tell your neighbor. Two perfect squares that 19.4 falls between. All right, in 5 seconds. Very good. TT, what did you get?
I got, 1 point.
Don't make it too hard. Like root 19.4 is between which, like what perfect square is right before 19.4? So these are your perfect squares, right? Your 1, your 4, your 9, your 16, your 25. Yeah. Okay, so you're giving me the answer now. So it's between root 16 and between root 25, right? And so this is 4 and this is 5. So 19.4 has to fall between these two whole numbers. Why? Because 19.4 is between 16 and 25, and those are perfect squares. So it's a way for you to estimate your perfect square. So if I said to Jake, I go, hey Jake, what is the square root of 8.7? He may not know that in his head, but he should know what two perfect squares it falls between. Okay? So what perfect square is right before this one?
4 and 9.
Good, yeah, it's between root 4 and root 9, which means it's between which two whole numbers?
2 and
2
3.
and 3. Which one's it closer to?
9, so 3.
Yeah, it's probably closer to 3. Like if you had to guess, this is like the $1 million question. You got it right to the nearest tenth, you would win $1 million. I would say like, well, probably 2.9. Okay, because really close to 9. I don't know if I won the million. I have no idea. Did I win the million? What was it? 2.8?
No, it's
Root 8.7? Oh, is it like 2.9 something?
yeah.
9 what? Come on, I want to know if I won the million. 2.9. 9.4, yeah, dude. It rounds down. I win the million right there. If there was a million, but because there's no million, unless someone's giving me $1 million for it. Okay, it's in between 2 and 3. That's the whole point. All right. Not that I win $1 million, because who cares? It's only money. All right. So up through 50. Here you go.
Okay.
All right. 43, what did we get? Everyone. 6 and 7. Now, how do we have to change that? TT? Yeah, make it negative because the negative sign there. Okay? So negative 6 and 7. How about 44?
6 and 7.
6 and 7 again. Unbelievable. Except for not negative this time. How about 45?
Negative 10 and negative 11.
Negative 10, negative 11. Okay? 46?
12 and 13.
47?
15, 16.
Okay, why is Bobby the only one giving me the answers now? Come on. 48. Negative 4, negative 5. Whoa, that's double negative. Thank you. All right. 49? Almost. How about 9 and 10? Good. 40-10, also known as 50. Negative 2 and negative 3. Good. All right, any questions? That was our non-quick, quick warm-up of perfect squares. Okay? Non-quick, quick warm-up. All right. Now we're ready for 7-5. Amazing joy. Okay. So 7-5. Get up the notes here real quick. Our goal today is going to be to solve quadratic equations. Now this is different than when we factored. Some of you are going to recognize some of these. You're going to be like, hey, I factored ones like that, but it's a bit different, okay? We're going to solve quadratic equations in the form of ax squared equals c. Okay? Notice what's missing. Tell your neighbor what's missing.
B is missing.
What's missing?
B.
B missing, okay? B is missing here. All right, so finding the quadratic equation has two solutions, one solution or no solution. That's our other goal. So we're going to go in this form. B is missing, meaning we're not going to have to factor them. Remember, B be the problem when you're solving and when you're graphing. It makes them a lot more difficult. Okay, before we do that, let's make sure that we're clear on what the solutions are going to tell us. Let you get this down in your notes first, real quick. Okay? I feel like you guys are ready. Here we go. You get the next 2 minutes or so to work on that with your partner. Okay? Find the x-intercepts of each graph. Number 2, use the graph in question 1a. Find the solution of that equation. And number 3 are the x-intercepts found in question 1b, the solutions of that. Go for it. Hey, wrap it up next 10 seconds, please. All right, volunteer. What's the x-intercept here? TT. 3 halves. Everyone agree it's 3 halves? Did anyone say 1.5? Same thing as 3 halves. Okay, how'd you get 3 halves, TT? Okay, so the x-intercept is when y is 0, so you say y equals 2x minus 3. And if 0 equals 2x minus 3, then what'd you do? Add 3, so 3 equals 2x, and then divide by 2, x equals 3 halves. Sounds pretty good to me. Good. Yeah? Is that the same as 3 halves?
Yeah.
Yeah, so that's right. Good. Use the graph in 1a to find the solution of this. Well, dude, TT did that. Well done, TT. It's like 2 for 1. All right. Good. Any questions there? So your x-intercept is when y is 0. That's what to take away from there, right? And so if I'm finding the x-intercepts here, it's when y equals 0. Well, remember, when we were graphing these, or dealing with these earlier on, we had a y in here, we put 0 in, and we could go through and try to factor. Well, in this case, we have an x-intercept of negative 3 and 1. Is that negative 3 and 1 is the same thing we would get if we would have factored this equation. Two things that multiply by 3 and add negative 2, but we got a negative out here, so we have to deal with that. But when we were factoring last chapter, that allowed us, when we were factoring last chapter, it allowed us to find these points on our graph. Okay? That's what we're going to be doing while we're doing today's assignment. All right? So, that being said, I want you to take a look at number 8 here. It says use a calculator to solve for this guy, round your answer to the nearest tenth, and then find the values of c. So you're going to put numbers in here so that this will have 2 solutions, 11 and negative 11. Okay? I want you to give it a go right now. All right, we're going to move on. X squared minus 7 equals 0. What's our answer? X squared equals 7. Everyone get that far? Then what'd you do? How did you undo squaring something? Quickly. Take square root. Good. Undo squaring, take the root, they cancel. Now, whenever you, in this case, if I take the square root of 7, you guys say it's 2 point what? 6. I could estimate it, right? It's in between 2 and 3 because it's in between root 4 and root 9. It's closer to root 9, so it's about 2.6. Now, that means 2.6 times 2.6 approximately makes 7. Everyone agree with that? Okay. What if I told you that there's a second answer here? There's another number multiplied by itself that makes 7 as well. Root 7. Yeah? Yeah. Negative 2.6 times negative 2.6. What's a negative times a negative? Positive. So anytime you impose, or the other way to think about it, anytime you start a problem and there's not a square root, and at some point you put the square root in, you've got to put a plus and minus in between, or in front of it. Because that means when you're squaring something, you could have the positive version, and when you're squaring a negative, you also get a positive answer. That makes sense? So if I said, hey, what two numbers multiply to make the 9? Most of you would say, well, I know what's the answer here. Correct. Yeah, it's 3, right? Because 3 times 3 is 9. Well, technically it's plus minus 3, right? Because negative 3 times negative 3 is also 9. How did you get that? Well, you impose a square root. Okay? To find that answer, you have to take the square root of 9. That's really what you're doing. And you have to put that plus minus, which gives you plus minus 3. Okay, so make sure that if you're taking the square root, starting a problem without it, and somewhere in the problem putting a square root, you've got to put plus minus. Questions there? It's a good thing to add to your notes. Otherwise, some of you are going to miss half the points on your test. You're going to be like, dude, I killed that test. And then you get it back and you got 50% because you didn't put plus minus. That's not good. All right? So make sure it's highlighted in your notes. However you highlight things, if you're like, I just remember, that's what I do. Well, and then you don't, that's not good. Find two values of C that will make our two solutions 11 and negative 11. Anyone find the values? TT found them? Anyone else? Tell your neighbor what you got, or what you did to try to find those values. All right. Hey, you guys, if I was solving this equation and this was a number here, how would I move that number over?
Add it.
I'd add it. So I'd have x squared equals, what am I adding to both sides right now?
C.
C. X squared equals C. So in other words, what squared will make positive negative 11? That's what you want to know. Okay, or when you're squaring positive negative 11, what do you get? TT, what'd you get? 121, yeah. Okay. X squared is equal to 121, so when I take the root of that, okay, plus minus root 121, which is plus minus 11. All right. So that's what we're going to be doing today. We're going to be solving a bunch of problems like that. All right, any questions? Okay. I want you to look at set 1 here. Without actually doing the problems, like on paper, I want you to tell your neighbor as many of those answers as you can. Okay, you can just like sketch, you just like write the answers quickly on a piece of paper. Go for it. What did we get here? You three over there, what'd you get?
4.
You got 4? X equals 4?
Yes.
How'd you do that? Took the square root of 16. Audrey, Jake, you agree? Okay. What do you do when you put a square root? Plus minus. So really, what's our answer? Plus minus 4. Well done. Okay, that's our answer. Good. Now, a lot of times you'll see these in set notation. We'll write it like this. We'll put a parenthesis there with an arrow and another parenthesis. That's called set notation. Why? Because there's more than one answer, so we put set notation so that we know. Okay? Number 2, you 3 right? Yeah, Jake. Oh, you got 3? For number 2? I was going to give it to those 3. What do you guys have? Chelsea? Plus minus 9. X equals plus minus 9. How many agree? I agree as well. Okay, set notation because we're cool like that. Okay? Plus, if you really look at a set piece like that and you put an eyeball and a little hair and a face, looks like a creepy dude. Yeah, I know. It's pretty cool. All right. X squared equals 27. What do we get there? 5.2. So x equals root 27 plus minus, right? Don't forget that, otherwise you lose half credit. So plus minus 5.2, did you round to the nearest 10? Yes? Cole, do you agree? Okay. Very good. Round to the nearest 10th. How about number 4? Lily, Caden, Mackenzie, what do you guys think? Negative 4? What number times itself will make a negative? Everyone tell your neighbor any number that you can multiply by itself to make a negative number. So positive 4 times positive 4 will make negative 16? How about negative 4 times negative 4? No. How about positive 4 times negative 4?
Yeah.
Yeah, but is that the same number?
No.
Like if I say, hey, Lily, give me $4. And then I go, no, I changed my mind. Give me negative $4. Is that the same? No?
You would give her $4.
Yeah, I'd have to give her money. Then that's not going to happen. Okay? So, x squared equals negative 16. You can't square something and get a negative. That's no solution. It's got no soul, man. Okay?
No soul.
All right. Okay, let's move on. Set number 2. Tell your neighbor what you're going to do first in set 2. Okay, what do we do first? You guys right here, since you didn't get a chance last. I don't want to cheat you guys out of anything.
Oh, we're going to add the 6th.
Okay, Bobby says add 6. How many of you over here agree? Yes? Add 6. We'll add 6. Well done, Bobby. X squared equals 49. Now we should know what to do, right? It's just like the previous set. What do we do from there? We take the root. What do you need to put? Positive negative, root 49, which is positive negative 7. Are you positive? Yep. And negative. Totally sure. There we go. Put the cool brackets. Plus minus root 7. Or plus minus 7. Is number 14 no solution? Why don't you figure out number 14 real quick with your groupies. What do I do first in number 14? Ayla, what do I do? Yeah, divide by negative 2. Now, what's a negative divided by a negative?
Positive.
Positive. So don't be so quick to judge and say, hey, that's going to be no solution because I have a negative over here. When you divide that negative by a negative, you get a positive. In this case, positive 121. And then I take the root, which gives me plus minus 11. Now, how many got that right? That doesn't surprise me. It's pretty brilliant. Okay. Questions? All right. Why don't you try to? Everyone try number 17, please. 17. All right. Volunteer to tell me the first step. TT. Minus 20. How many did that first? Good job. So 5x squared equals 125. Second step. Lily? Divide by 5. How many divided by 5 next? Well done. X squared equals? Equals 25, right? And now what's next? Last step? Yeah? Yeah, take the square root of 25. And it's plus minus, right? Plus minus root 25 is? Equals plus minus 5. How many got it right? That is the answer. Well done. Hey, your assignment? Well, first, questions? Assignment is the other side, 1 through 24. Some are easy, some are a little more involved. However, none will be any more difficult than the last one we did. Shouldn't take any more than 2 steps. Okay? You can do it. In fact, I could guess that a good chunk of it you could do before you leave. You got 5 minutes. Go for it.